Hi, welcome to the Imatest booth. Today we have our VCX webcam chart. It's used for putting a human face in the scene, changes the processing, and we can measure the camera response under different webcam conditions. We have a computer displaying our Imatest master software. It's connected to a demo camera that is taking a picture of one of our high dynamic range charts. That, of course, is on our Benchtop Test Stand. It's an easy and convenient way to keep cameras and test charts aligned, control test distance on a small space. And then we also have on display some of our different test chart options. We have high precision chrome on glass targets right next to a smaller uh, reflective color chart, useful for endoscope testing. And that is next to the new ISO 12233 2023 version of the new resolution chart. Thanks for stopping by.
New version of ISO 12233 was published last year. In particular, the slant edge algorithm was updated significantly. Cosine angle correction, higher order polynomial fit, different apodization options have all improved the accuracy of the SFR measurements from a slanted edge. So I've been through the pain of figuring out how to deal with these stars. I'm going to be showing evidence and arguing that we should be considering different kinds of ROIs, diagonal ROIs or wedge ROIs, which are better suited for the shape of the star itself. That's everything.
So this is our demonstration for evaluating the noise of HDR image sensors according to the IEEE P2020 standard, which is still being developed. So over here we've got a light box with a 36 patch chart on there. This light box gets up to 10,000 lux at the surface. We've got one that gets up to 100,000 lux. And that's what you see here. This is a pre-recorded video. There's the live feed. The objective here with this video is to saturate the brightest patches, which can be really hard for these high dynamic range sensors, which have over 140 decibels of dynamic range, theoretically. The lens itself is what's limiting the dynamic range because there's this stray light, ghost reflections that you can see. And the veiling glare is overlapping with the darkest patches. So what that does is it elevates the signal in those patches, and it leads to higher than expected SNR measurement. So it's actually impeding the measurement in a way. What you have to do is you have to take these videos at multiple light levels to be able to evaluate the full range of the sensor.
The first important metric that we come up with is the noise equivalent quantum. And that's a frequency-dependent signal-to-noise ratio. And when you have an image where the noise is dominated by photon shot noise, it's equivalent to the number of quantas that would generate the SNR. It's used somewhat in medical imaging, and it has a fairly simple form as long as you know the MTF and the noise power spectrum. Now, we define the kernel of the calculation a little bit more later on, that is the MTF squared. Thank you.